Hello YouTube. In this video, I'm going to be showing you how to use C#'s reflection techniques inside of Unity and how they can be useful for you. So the biggest thing with reflection techniques in Unity is that it's very useful for debugging, and it's also the entire basis of the Unity engine. It's how inspectors here are generated and how properties are read from values in C#. So reflection, in a simplified sense, is the theory that in the application domain, which would be Unity and our game, inside of every assembly, there exists the modules that contain enums, types, and delegates. And through reflection, we should be able to find out types and fields on an object and be able to expose those to a UI inside of Unity. So one of the biggest reasons I can think to do this instead of just using the Unity inspector is that one, you might just be sending a build off to somebody who doesn't have Unity on their computer and they just need a quick way to get some debug information, and you could build this screen into the game for them. Or as a convenience for you to pre-build in some functions or debug if you're using reflection to generate code at runtime or generate objects at runtime like I'm going to be doing. This simple application we're going to be building today is going to reflect some data stored on our object in the scene here. So I've set up this simple 2D test scene. We've got a main camera with a physics 2D raycaster on it. That's important so that our corgi can respond to a pointer click here. It's just a 2D sprite, and we've got a box collider and a rigid body 2D here, along with a script called debug on click. And this will come into play later, but we're going to use some injection techniques to make sure that this script gets a reflection UI reference. And if we come into our test canvas here, I'll just go ahead and show this and bring this interactable and all that. So this canvas here is going to be where our object's properties are displayed. So we're going to almost create a mini Unity inspector here inside of our game. And we're going to make sure that all our properties get placed underneath this reflected object property. And I've already pre-attached a script called reflection UI here, and this is the script that we're going to be creating in this episode. And essentially what this script is going to do is that any object that references this script or this UI object will be able to tell this script, hey, I want you to reflect this object. It doesn't matter what type of object it is, since we're just accepting the generic C# object, which everything reflects from. And tell me the type it is, and tell me what public and or private fields. So I've been testing this out a little bit already in Unity this morning, and I found that it's working pretty well. So let's see if we can re-implement this. Just going to go ahead and open our reflection UI script here. Okay, so this is just a blank mono behavior, and you see I've put it in a namespace. So the first thing we want to do with this debug UI essentially is I'm just going to come here and I'm going to create a few Unity fields for an input field. So this is going to be our input field prefab. Another for button, and I'm also going to make one for a default font. Okay, so the input field and the button prefabs here, these are really just convenience things. You could have these pointed to a pre-made object in your scene somewhere. I have already created them as prefabs though. As you can see, I've hidden this prefabbed area over here. And the only thing I really did was configure some changes that I've made to the input field, the button, and the scroll view. Essentially, the button is now best fitting its text. The input field, usually I'm changing the text on, and I've also added a layout element so it's at a preferred height of 40. Again, this is something optional you can do. And the scroll view got the most changes because I went ahead and disabled horizontal scrolling, and I also came to the content viewport here, added a vertical layout group with the following properties here. Control child size is only set to width for a reason, and a content size fitter so that no matter how much content we have in here, it'll automatically try to fit this content rect, and the scroll rect will take care of scrolling and showing different parts of it for us. So that way we don't have to worry about configuring these objects when we create the object or setting up all these objects manually. Because when you create them through the UI like this, they come pre-configured. When you create a game object through code and then assign it an input field or a button or a scroll view, they don't get pre-configured automatically. So we're referencing those as prefabs to make our life easy. And I'm going to go ahead and assign these references to our default here. Make sure that it's referencing the assets on the disk in the project view. And for our default font, I'm just going to set it to the built-in aerial. I'm not actually doing anything super interesting yet, but I'm going to go ahead and add a couple more private fields. So the first one is going to be our private object. We're going to store a reference to our serialized object here. And we're also going to store a reference to the type. And we're going to need to go ahead and import system and also system.reflection eventually too, but not yet. Okay, and the last thing we're going to do is an internal transform. We're going to call this component add parent, and we're making this internal so that if we derive a class from this reflection UI later, we can go ahead and change this component add parent. And all this does really on this script is it's going to point to our transform and say, hey, add any components related to reflection to our transform. They're going to be parented to us. In my awake, I'm going to make sure that that is explicit, and I'm going to make this a public void awake, so any scripts that inherit from this can override this later. I'm going to say our component add parent is equal to our transform. So we're almost at the fun part now. We're going to write the method that generates our UI based on our object. So I'm going to call this public void generate UI for value, and we're going to pass in our raw C# object right here. And now this is where we're going to start to use reflection. Now, we can pass this any object, but we've automatically discarded any type information about it. But that's okay, because we want to use reflection to acquire that type information, and then use reflection to also use that type information to iterate over public fields or private fields. So the first thing we're going to do is we're going to set our serialized object to our value. We're going to set our serialized object type to value.getType. And this value.getType will point to whatever type information we discarded when we passed our object to this function. So it should get that back. It's pretty easy at this point to get all the fields on an object. And the way you do that is with our serialized object type.getFields. Now, you need to have a type assigned to a variable here to use this, or you could just do getType.getFields. But the point is you have to have a type, and I'm going to pass some arguments into this because by default, if you just do get fields, it's going to retrieve only public fields. And that's probably fine for what you want, but I really wanted to be able to reflect my private fields, and I know it's possible in the C# framework. I can't promise that this will work for IL to CPP platforms such as iOS, Android, and Mac. It seems to be working great on Mac. I can't promise especially it'll work on iOS. So we're going to get our fields, and we're going to set some binding flags here. So that's binding flags.public, and we also want binding flags.nonpublic. We also want binding flags.instance and binding flags.flatten hierarchy. Now, I've done some experimentation and tried different combinations of these fields individually. The only way I could get it to work in Unity was by ORing all of these together. And again, if you just wanted public fields, you could remove this altogether because the default is binding flags.public. But again, I wanted all the fields. So we've got all our fields on our object that we've been passed now. I want to remind you all that we have assigned this object and the object's type to some properties on our mono behavior, so we can get those later. And we're using reflections to get the public and private fields on our serialized object type. So now we want to iterate over those, and I'm just going to say for each field info in all the fields. Now's the fun part. We've used reflection to get the field infos. Now we're going to use reflection to get the name of the field and also the value of the field. Now this is where things get interesting because once again, we're working with just this generic C# object type. So it'll work pretty well when we want to just view types, but when we want to assign, we have to be very careful with how we cast our types. And I'll show you how that works in another video. But for now, we're just going to reflect and view these fields. What I'm going to do, first of all, is I'm going to get the value of this field. Field value is equal to fieldinfo.getValue. And what it's going to ask for when you call fieldinfo.getValue is the actual object reference that you want to get the value from. So just right now, if we were to get value, it would throw an exception because we're really just referencing a field on a type. We're not referencing a field on an instance. So when we call get value, we're going to pass it our object value that we passed in at the beginning up here because this is our reference or pointer, and get value wants the pointer to that object so it can properly return the right value. So what I'm going to say is if this field value is equal to null or is not equal to null, Then let's generate our UI. Now I'm going to make a separate method to generate this UI, mostly for convenience sake, but there's actually a couple methods involved with this. So the first thing we want to do is make sure that we're adding a label and an input of some kind. So in our case, we're going to be doing a label and an input field. And those should be parented to one rect transform and then added into our scroll view. So what we're going to do first is configure the rect transform. And we're going to call this generate property parent. We're going to say, give me a property name and give me a parent. This is just standard Unity object generation and adding components. I'm just going to copy and paste this from somewhere else because I've got it somewhere else already. We're creating a game object with the name, property name grouping so that we know, okay, it's the grouping for this property name on this object. We're adding a rect transform to it because it's UI, and then we're adding a horizontal layout group so that we go label, and then to the right of it, input field. We're saying child force expand height false here. That's mostly to do with the layout element preferences on our input field. You don't have to do that. And then of course, we're setting the parent to the parent that we've passed in the function and returning the property parent back. I'm also going to create another convenience method here called create default text, create a new game object, set the parent, add the text component, and I'm enabling resize text for best fit, and I'm also setting the font to our default font. And then I'm just going to return the new text property. All right, so that's another convenience method down. And finally, the last convenience method I'm going to do is the one that's actually going to generate the complete UI. So what I'm going to say is private void generate label with text field. And we want to pass it a property name, an object property value. And what this is going to do is it's going to use our other convenience methods to generate some UI based on the property name and the property value that we are passing this via reflection. So we're going to create our property parent. We're going to use our convenience method here, and I'm just going to insert the name here as property name, and the parent is going to be the component add parent that we've assigned earlier. Next, we're going to create a label, which is just going to have the name of the field. So we're going to call this property label, and that's going to be equal to create default text here, our other convenience method rather, property name label like so. And once again, we're going to make, actually not once again, we're going to make this a parent of our property parent instead of the component add parent. See how this hierarchy is coming along, I hope. And I'm going to make sure that I set our property label text to our property name. And why not? I'm going to add this in here. Is public, right? And C# has dictated that I cannot do that inline like that. So I'm just going to have it like that. Okay, so now that we know if it's public or private and what our property name is going to be, let's create the actual, let's instantiate the input field that's going to display a value for us. So we're going to instantiate this based on our prefab. So our property input is going to be equal to instantiate our input field prefab. And we have to give it a starting position, but it doesn't really matter. So I'm going to pass it vector30 since the list will assign it anyway. And we might want to make sure that we set this input transform parent to the property parent too. And finally, we'll do our own null check handling here. If property parent, or I'm sorry, property value is equal to null, we'll do something here. Else, we'll say property input.text is equal to null, like that. Otherwise, our property input.text is going to be equal to our property value dot toString. And just for posterity's sake, we haven't hooked up our input handling yet. So I'm just going to say that these are all read-only, and that's equal to true. Okay, so what we've done here is we've created a property parent, and then we've added a property label and a property input to that parent. This property parent is going to horizontally lay out those, and then it's going to get placed inside of our component add parent, which, as you recall, is our transform. So let's go ahead and hook this up in here. So we'll generate our UI. And actually, we can skip this null check here, because all we have to do is call generate label with text field. Is public is going to be the value of field info.isPublic. We'll just pass that right in. Our property name is just going to be fieldinfo.name. And our object property value is going to be equal to fieldinfo.getValue. And once again, we're going to pass it in our object pointer right here. We're going to get the value of that field based on that object pointer. Okay, so when this method is called and we've passed it in an object, what it's going to do is it's going to iterate on all the fields on the object, and it's going to generate some UI in our scroll view based on that. Everything looks pretty good here. This is a pretty small class. So let's go ahead and minimize this. Don't see any errors, just a couple C# warnings that we can safely ignore this time. Now there is still one problem. We could manually say, or manually assign a reflection UI reference here. But let's do some loose dependency injection here. Let's give you a quick primer on that. You don't really need a huge framework for this. You can do it yourself. Our debug on click implements an interface called iSupportsReflection. And this iSupportsReflection interface states that we should have a reflection UI and a void called reflectMe. So of course, I've got our to-do here to say we need to tell our reflection UI reference that we want to reflect it. And implementing this interface is giving me a preflection UI too, along with our reflectMe method. This preflection UI just points to the serialized Unity method we were pointing to before. We've also implemented iPointerClick handler, which is why we had a physics raycaster and colliders attached to this test object, so that way we can intercept pointer clicks to say when we click on this object, let's show reflection for it. So how do we show reflection for it? Well, we're just going to say reflection UI reference dot generate UI for value, and we're just going to pass it in this. We still haven't assigned this, and once again, we could manually assign it, or we could do a basic form of dependency injection in which we look at every object in the scene, and if it has an iSupportsReflection behavior on it, let's go ahead and get that behavior and inject our preflection UI. And maybe it's not truly dependency injection because it's not being done with a composition route, but whatever. I'm just going to say in here, inject iSupportsReflection. Okay, so we're going to use Unity engine.object.find objects of type to find all our transforms active. And then what we're going to do is we're going to iterate all of our transforms here, and if potential.gameObject.getComponent iSupportsReflection. And if it has our iSupportsReflection component, then what we can say is supports reflection, or I'm sorry, the reference to our component dot underscore reflection UI is equal to this. And boom, just like that, we found every transform in the scene, which means scene objects. And we're checking to see if it has an iSupportsReflection behavior. It doesn't matter what the behavior is, as long as it implements this interface, it'll find it. And when it finds it, it'll assign the reflection UI to us. So that's our basic form of dependency injection here. So let's go ahead and call this when we awake. I'm going to go ahead and hide this canvas for a second. And if we come and start the game, we should see here, boom, we have a reflection UI reference. So our basic dependency injection worked there. Now there is one more thing I'm forgetting about, of course, and that is the fact that we want to store our canvas group so we can show and hide it properly. So that's going to be another Unity reference. So I'm going to call say this is serialized field canvas group like so. And that'll be assigned through the inspector. So we can say generate UI for value, and I'm just going to make another helper method here. All right, and when we call generate UI for value, we're going to do our generation, and then we're going to set our canvas group to true. Okay, so I thought I'd share some more insight with you. So apparently you cannot just reflect on a Unity game object at runtime. You can reflect on a mono behavior because if I click on this, you can see just reflecting on the debug on click mono behavior, you can see that this does match our class definition here. We have a private UI reflection reference here, and you can see it is assigned to a reflected object here. Gives you the type even. But it did not serialize the properties, and of course it won't show you methods. If I go ahead and try and change this to this.gameObject, and then try and click, you can see nothing shows up. creating 0 UI. Well, that 0 is taken directly from the field info on that object. So Unity does not let you reflect on the Unity engine.gameObject type. However, though, it seems you can reflect on any types you create. So to show this working in action, I've created this little testing struct here, and it's just got a bunch of data attached to it, as a struct should. And your scriptable objects will probably look something like this in Unity. If the scriptable objects are a type you've created, chances are you'll be able to reflect on it regardless of what its base game object or scriptable object type is. I'm creating a default data here with a public static method. This is essentially a factory method for those who care, and just with some test data. So let's go ahead and create a default of this and try and serialize this instead. Okay, coming back from an auto warranty call, we are going to reflect our type that we created. It's a custom struct for storing data. So if I click on the corgi head, you can see we've reflected everything in that struct. If I come to our debug on click and look at our test struct data, you can see what was serialized. We've got our test int there. That looks like an integer to me. Our test long kind of looks like a long to me. Can't say for sure. Test short, test byte, a test character, a test string. We've got our testing enum, which serialized the enum's name rather than the enum's integer value, which I guess is good. And you can see we've got a testing class here. Now, if this were null, it would say null. But since we've got an instance here, I've just reflected the type of the instance that's here, just like what Unity does. The only difference is that Unity has a little knob here, so you can assign the reference. Okay, so I hope you guys enjoyed this short intro to reflection in Unity. It might not be so short when you guys see it, but in the next video, we'll go over reading and writing these values and how to ensure that they update when you read and write to them. Until next time, guys, I'll see ya.